Hello, this is Varun Bhaskran, a chemistry instructor at Key Prep, and today we'll be talking about balancing equations. So, why do we balance equations? Balanced chemical equations show the conservation of mass, such that the number and type of atoms on the left side of the arrow equal to the number and type of atoms on the right side of the arrow. These equations are very important when solving problems in chemistry. We always want a balanced equation. So, how do we balance equations? So first, we write a vertical list of elements present and count the number of atoms of each side. Second, we place the whole number coefficients in front of chemical formulas in a trial and error attempt to have the same number of atoms present on both sides of the equation. Multiplying the coefficients and the subscript will give you the number of atoms present for that element. So, a couple tips when balancing equations. Balance the hydrogen and oxygen last. Never change the subscripts on a given chemical formula. If a word sentence is given, first translate it into proper chemical formulas, then balance the equation. If you are unable to balance it, it is possible that the chemical formulas are written incorrectly. Okay, so classification of chemical reactions. There are five different types of chemical equations. The first one includes synthesis, in which element A plus element B will give you element AB. Decomposition, in which element AB will decompose to form element A plus element B. Now, combustion is the special one in which a carbon, you see how it has carbon, hydrogen, and oxygen. So the X, Y, Z, so it could have a subscript of any variable, plus O2 will yield carbon dioxide plus H2O. So the products will always remain the same. A combustion reaction will always produce carbon dioxide plus water. Now the other two are single replacement and double replacement, in which element A plus element BC will yield element AC plus element B. And another way we can say this is element D plus element BC will yield element BD plus element C. Now, double replacement is when element AB plus element CD yield element AD plus CB. So they're switched, both of them are replaced. Now, a way we can look at this is we can focus on Mario and Luigi. So on the left side of the equation, we have Mario and Luigi. So element Mario plus element Luigi plus Yoshi, basically. So as you can see, on the right side of the equation, we have Mario with Yoshi and Luigi's by himself. Now, for double replacement, I like to think of it as a double date. So you can see that Mario begins with Daisy plus Luigi with Peach. And now on the right side of the equation, Mario is with Princess Peach and then Luigi's with Daisy. So they both switch. Now, some chemical equation symbols to note. So these are all how to determine if it was a solid, liquid, gas, or aqueous. That is all on the solubility chart. But so the solid would be our lowercase s, the liquid would be a lowercase l, the gas would be lowercase g, and aqueous / soluble in water would be aqueous, so it'd be AQ. The yield sign is a arrow pointing to the right, and reversible is pointing both ways, which means that the equation is reversible, and heat is the delta sign. So for some quick notes, for single replacement reactions, you may need to look at an activity series chart to see if the element is able to swap places with one element within the compound. And combustion reactions will always require O2 and will always become carbon dioxide, which is CO2, plus water, which is H2O on the product side. So, example questions. We need to classify the following reactions. So we have 2Al, which is aluminum, plus 3Br2, which is bromide. So when it yields 2 aluminum bromide. Okay, so for this problem, it'd be synthesis, because we can see that it's the element A plus element B, which yields us element AB. Okay, let's go on to the next one. We have 2Al, which is aluminum, plus 2Fe2O3. So iron 2 oxide. Iron oxide, yes. So we can see that it yields 2 iron plus aluminum oxide as well. Aluminum oxide. So what do you guys think this one would be? This one would be single replacement, because it is element A plus element BC, which yields element AC plus B. So you can see how the aluminum kicks out the iron, and now attaches with the oxygen. So let's move on. We have HCl plus NaOH yields H2O plus NaCl. So this one would be a double replacement. So we have AB plus CD, which gives us AD plus CB. So as you can see, the HCl breaks apart, and the H bonds with the OH, which gives us H2O. So there's two H's and one O. And then the Cl bonds with the Na. So it becomes NaCl. Now, to balance the following equation. So we have the following equation here. We need to balance those out. So we'll be going to our sketch pad. So first, we have to write a vertical list of the elements, which I have here: nitrogen, hydrogen, oxygen. And at the start, we don't want to start with hydrogen or oxygen, so we're going to start with nitrogen. So there's only one nitrogen on both sides, so the nitrogens are balanced. Okay. Now, there are 3 hydrogens on the reactant side, so this side. So 3 hydrogens on this side, correct? And there are 2 on the product side. 2, so those are not balanced. So what we need to do is we need to balance it with the least common multiple. So that would give us 6. So what we're going to do is we're going to put a 3 here to make that 6, and then we're going to put 2 here. Okay. Now, if we do that, that means we need to multiply 2 to our NH3, and then exactly. So now there are 2 ends on the reactant side. So there's 2 ends on the reactant side, but there's only 1 here. So now we can cross these out because the hydrogens are balanced. So there's 6, because 3 times 2, 6, and then 2 times 3, which gives you 6. So we have 6 on both sides. But now the nitrogens are unbalanced. So now 2 ends on the reactant side, and there's 1 end on the product side, meaning we need to multiply the 2 to NO to balance the ends, right? So we're going to put a 2 here. If we do that, we cancel this out, and we put 2 here, which means that this 2 also goes to that oxygen. So now there's 2 O's on the product side. There's 2 O's there's 2 O's on the reactant side. Sorry. So 2 O's. So from this O2, and then there are 5 from the product side, because 2 times O, which is 2, and then 3 times O, so 2 plus 3, that gives us 5. So our nitrogen and hydrogen are both balanced, but we cannot have a 2.5. We cannot multiply this by 2.5. So what we need to do is we need to go right here. If we put a 2.5, then we have a balanced equation, but we are not allowed to do that. The 2.5 is not allowed. So what we're going to do is we're going to rewrite this whole equation by multiplying everything by 2. So this entire equation multiplied by 2. So I'll rewrite it here. So that would give us 4 NH3 plus 5 O2, which gives us 4 nitrogen oxide plus 6 H2O, also known as water. Now we can check our oxygen C. So we have 4 nitrogens on the right side. We have 4 nitrogens on the left side. So I'll cross these out. So we have 4 and we have 4. We have 4 times 3, which is for the hydrogen. So we have 12 hydrogens here. And then we have 6 times 2, which is also 12. So we have 12 hydrogens on both sides. We have 5 times O2, 5 times 2, which gives us 10 here. So we have 10 here. And then we have 4, from this one, so we have 4. And then we have 6 times 1, so that's 6. And then when we add those, we have 10. So 4, 4, check. We have 12, 12, check. 10, 10, check. So our final balanced equation is 4NH3 plus 5O2, which is equal to 4NO plus 6H2O.